Alright, so I do want you to write every single fact down. Research shows that if you write it versus texting it or just listening, it's definitely going to stay with you. You can, of course, shorten these things, though. So let me get a highlighter. So the sun is medium-sized, and we know it's a star. It creates energy through fusion. Remember when we learned about radioactivity, we know what fusion is. It's hydrogen coming together and forming helium. So you should write, the sun creates energy through fusion of hydrogen and helium. And this does happen in the core. Seasons are caused by the tilt of the Earth. So seasons caused by the tilt of Earth. Again, we're going to go more into detail of that in class. The moon goes through phases because one side is always lit. So moon phases because one side is always lit. And we're going to go over what the phases are and how to recognize them. Mainly know that it's waxing when it's light on the right. Okay, and then it's waning if it's light on the left. So waxing, light on the right, and if you remember that, you know the other one is opposite. This has them in order. If you don't already know them in order, you may want to write all of these. Okay, the International Space Station, or known as the ISS, it orbits the Earth. Lots of different countries send people up there to do experiments. You just need to know that it does stay up in the exosphere orbiting the Earth. So we're going to say a large space station orbiting the Earth. Many countries use it. Many countries are there. That's good enough. Okay, solar winds. If we just said that the sun's going through fusion, it has to be releasing some kind of radioactive particles. And that's what we call the solar winds. It's releasing a lot, actually. So the radioactive particles that come from the sun outward. We are protected, though, by the magnetosphere and the atmospheric layers, although some of that radiation does still get in. I do want you to know that we're protected by the magnetosphere. Okay, Ptolemy said, if we go way back, that the Earth was in the middle. He thought the Earth was the center and that it was a geocentric system. Okay, so they may show you a picture with the Earth in the middle and say, first, what kind of system is this? Secondly, who is the person that proposed this idea? Copernicus, based on the moon phases, he said that, and also the phases on Venus, that it had to be that the sun was in the middle. So he called this heliocentric. Helio means sun. And of course everyone laughed at him and thought he wasn't very smart, but in reality he was correct. Alright, so here's a picture of each one. You can see in this one the Earth is in the middle with the sun going around it. And then over here we had the sun in the middle, and both of their ideas are still not all the way correct. Take a second and see if you can notice what is not correct. What do we believe is different now? Okay, so Kepler comes along much later. He says that the planets do not orbit in perfect circles. Instead, they move in ellipses. So he's responsible for determining that planets move in an ellipse, like a squished circle, more like an oval. And then Newton explains why this is even possible as far as the movement of the planets. And so he uses the idea of inertia. That's why planets just keep moving. Nothing's big enough to stop them. And the gravity of the sun keeps them in their specific orbit. Okay, so he says that inertia and gravity are responsible for how the planets move. We'll watch that in class. Okay, tides. Tides are caused by the gravity that exists between the Earth, Sun, and Moon. And there are two main types. A neap tide is the lowest high tide. So it's still a high tide, it's just the lowest high tide. And it's when they are perpendicular. So this is going to be a neap tide because the moon, earth, and sun are perpendicular. They are not perfectly lined up. A spring tide, if you think of springing up, is the highest of the high tides. And this is when they're in a perfect line. So the moon is either here as a new moon or it's over here as a full moon. Where in this one it's either in first quarter or last quarter. So when they're perfectly lined up, we get a spring tide. You should also know that there are 2 high and 2 low tides every 24 hours. Okay, meteor versus meteorite. A meteoroid is space debris. Okay, that means it's outside of our atmosphere. It's literally in space. A meteor is when it enters the atmosphere and gets burned up. So when we watch a shooting star or a meteor shower, that's what we're seeing, the rocks scraping along the different ice crystals in the mesosphere, and then they catch on fire from the friction and we see it. A meteorite is when it hits the earth. So it can be the size of a piece of rice, but that's a meteorite because it hits the earth. If it actually touches the ground, it's a meteorite. Okay, planets, we have 2 types. They can ask or use any of these terms. They may call them terrestrial, they may call them rocky, or inner. They're all the same. Mercury, Venus, Earth, Mars, moving from the sun outward. You do need to know the order, come up with a way to remember it. And then the gas, Jovian, or outer planets are Jupiter, Saturn, Uranus, and Neptune. And again, this is still from the order of the sun out. Make sure you know the whole complete order of the planets. Uranus is tilted on its axis. They believe something must have crashed into it at some point, big enough to flip it on its side. Venus is considered Earth's sister planet because they're almost exactly the same size. You can see them here next to each other. Venus is also the hottest planet, if they ask you that. It's covered in clouds and has extreme global warming. Mars is known as the red planet. Mercury is closest to the sun, so it has the shortest year. As you move out away from the sun, your year gets longer. That's something important to know. Mercury doesn't have an atmosphere, so the side facing the sun is seriously hot, and the side facing away from the sun is seriously cold. The asteroid belt falls between Jupiter and Mars. You definitely need to know this. I'm going to put Mercury, shortest year, 88 days, by the way, no atmosphere. Mars is the red planet. Venus is Earth's sister planet. Uranus is tilted. And then you should know the order of the planets. Okay, we're going to skip that. Sorry. Okay, revolution versus rotation. Everyone always mixes these up. Revolution is how long it takes to travel around the sun, so this is equal to 1 year. Earth's year is 365.25 days. Rotation is equal to 1 day. It's how long it turns on its own axis. It's like if you were to spin around. Okay, an Earth day is 24 hours. Now every planet has its own year and its own amount of time that equals a day. Okay, the way that you may remember it is that revolution is the longer of the 2 words, and so it would equal the year. The solar eclipse is when the moon is in the middle. That's the easiest way to remember that. So the Earth, sun, and moon line up, and the moon is in the middle, blocking out the sun. A lunar eclipse is when the Earth is in the middle. What ends up happening is the light from the sun is shining on the Earth and it gets bent, and only the red rays of light shine on the moon and it becomes blood red. We're going to skip this one. Okay, John Glenn is the first person to circle the Earth. So we're going to put first to circle the Earth. Apollo 11 is the first manned mission to the moon. They were in the module Eagle, which is where we get the Eagle has landed comment from. Neil Armstrong and Buzz Aldrin are not the only ones on there, but they were captain and co-captain, and they were the first to step on the moon. I imagine it was probably really scary, and they were like, you go. No, you go. Okay, the space station is a joint effort to create living quarters in space. The idea is that you could go there, stop, get food, get gas, or fuel of some kind, and then you could move forward and we've only been to the moon. Humans have not been past the moon. We have had satellites and probes landing on Mars and Venus, but not, and nothing has landed on Mercury. It's too close to the sun. Gravity would pull it into the sun. So just so you know, humans have only been to the moon, and that's it. Okay, the sun. This is all about the sun. The core is where fusion occurs. We kind of already said that. It's also the hottest area. Photo, remember, means light, so this is where the light comes from. Chromo means color, so this is where the color comes from, and these are the layers. The corona is the rays. It's the outer, it's kind of like what we see come around a cloud, the rays. It changes hydrogen to helium, we already said that, and the dark spots are called sunspots. They're actually cooler regions, even though they're not cool by our standards of cool. They're still extremely hot, but compared to what's around it, they're cooler. Alright, and that's actually where we're going to stop for today.